The kneecap is essentially suspended between the femur and the tibia. But we've talked about how the femur and tibia counter-rotate, 5 degrees or so. So what that's going to mean is that the kneecap is actually going to rotate. So go ahead and take your hands like we did earlier and imagine that the right hand is the right femur and the left hand is the right tibia, right? So I'm picturing these bones. And now when I bend the leg and they counter-rotate, the femur going out and the tibia going in, imagine now that the kneecap is being taken 5 degrees in that direction with the intercondylar groove, right? So it's attached down to the tibia, so that part is going to keep the bottom kind of where it is, and the top is going to rotate with the femur. So now we have a much more complex motion, which becomes very much like a swoosh. You know, the more I kind of learn biomechanics and feel the images in my body, the more I think that swoosh is really a brilliant piece of marketing, because it's got that sort of three-dimensional throw in this way that somehow indicates a very true form of movement. So go Nike. Okay, so what we're going to do is then we're going to drop the kneecap down, and remember it's going to start rocking. So it's going straight down and then it's rocking. And then we add the external rotation. It's very slight, but the tops of the kneecaps are going to go out and the bottoms will kind of stay where they're at. So it's down and slide and rotate, and then rotate in and slide back and rise up. And down and slide and rotate, and then rotate in, rise up. And down, slide, rotate, rotate in, slide up. Yeah? So, boom. And now an image that's kind of nice for this is like a skier coming to a stop once again in that swoosh pattern. But you can imagine how that skier, they really harness the force, right? They're really harnessing the force in order to stop, but it's not jerky at all. It's very smooth. Even from a very fast speed, even decelerating very quickly and stopping in a very short amount of time, the whole movement will be incredibly smooth. So try to feel that quality in the drop, slide, and rotate of the kneecap. Rotate back, slide up. And whoom, whoom, and whoom, whoom, and whoom, whoom. So another image I use a lot in my mind is a ski jumper. So you know how a ski jumper comes down the hill and then they go flying in the air off the jump, like the big distance ski jumpers. And as they go up, it's like the ground pulls away from them. Certainly in terms of relative motion, the ground is pulling away as much as they're rising up. So it's the same with the tibial plateau. So now you start to get this image where the ski jumper is the kneecap. The ski jump and hill are the intercondylar notch and the condyles, and then the ground is the tibial plateau. So it's this very kinetic image with all these different parts going on. And it's a way that I got to be able to image all these moving parts happening at once. So here we go, the ski jumper is going down the jump, then they're going off the jump, and then this image doesn't account for the rotation, but the tibial plateau is dropping down and forward, right? So you can think about that ground, that the ski jumper jumps and the ground drops. Boom. Ski jumper jumps and the ground drops. Boom. So tibial plateau drops away, kneecap rocks, goes down and rocks. Shoom. 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 And then you can imagine the pull from the tendons between the bottom and the kneecap and the ground or the tibia. So you can feel that the tibial plateau drops away and the kneecap drops down and then swerves out, but there's still this line of connection. And that's that angle that I was talking about, that the kneecap, because it's swerving out, is creating this really nice angle of pull for the leg. So go ahead and picture that. And I'm just imaging my left leg now as I do this with my hands. And then I can picture even the condyles, the wheels rolling back, that this hand, the kneecap, is resting in that groove. And all of a sudden my bend starts to naturally go deeper when I add that image. Then I switch sides. So I've got my tibial plateau, my kneecap, and then I'm imagining my femoral condyles, and So can you picture all these different moving parts, and then add the swerve back in, right? The rotation. And feel how the knee has all these three-dimensionally moving parts. They're twisting and rotating and bending, and that's how it's creating your ability to harness and produce all these forces. If you enjoyed this video, sign up for the Embody Space newsletter and share the link with a friend. You can also find original content on Facebook and Instagram.